Lesson 8.4, Inscribed Angles. An inscribed angle is an angle whose vertex is a point on a circle and whose two sides contain chords of the circle. So you can see that we have two angles inside of this circle, and we have MKL, which is a central angle, which you already know about, and now we have UVW. This angle is different. It does not have a vertex on the center of the circle. It does have two ends on the boundary of the circle. There's a relationship between inscribed angles and their intercepted arcs. In circle C, the measure of arc ZY is 60 because it intercepts the central angle ZCY that measures 60 degrees. I jumped forward. That's actually the next lesson, but I want to introduce it now. It makes things so much easier. So this central angle 60 will be the same degree measure as the arc ZY, and arc ZY will have the same measure as your central angle. Triangle VCX is isosceles. We know that because it has two congruent radii, and so it has two congruent base angles. Those two base angles are also the remote interior angles of the 60-degree exterior angle in this drawing. Now, one of the things I wanted to point out is that there are different ways to solve in these circles. One of the things I can show you is this is a diameter, which is a straight angle. So if we have 60 degrees, the other angle is 120. It's a central angle, so the arc that it intercepts will also be 120. And if we look at VY, it's a diameter, and if you take 180 from 60, that's 120 also. This is a semicircle, which will be 180 degrees, so there's more than one way to solve. Another thing that we know is because this angle VCZ is 120, that leaves us 60 degrees for the other two angles of the triangle, and they're congruent, so both of those angles will be 30 degrees. In this triangle, angle W and angle X appear to be 90 degrees. They're part of the diameter. Their angle ends both intercept the diameter, and we know that the semicircle equals 180 degrees. So if this is a 90-degree angle, it actually is 1/2 of the measure of 180, and that goes for angle W also. So both angle X and angle W would be 90 degrees. There are special cases of inscribed angles. You have a case where the center is on the inscribed angle. The center of the circle is on the angle. You have the case where the center is inside of the angle, and another case where the center is in the exterior. So you'll have the angle on one side or the other side of the center of the circle. We can reach the conclusion that the measure of an inscribed angle equals 1/2 the measure of the intercepted arc by looking at the last slide and determining that the 90-degree angles were 1/2 of 180, and now we have the theorem for that. So theorem 8.4.1, the measure of an inscribed angle is 1/2 the measure of the intercepted arc. So we have central angle measure will be equal to the measure of the intercepted arc. Inscribed angle measure will be 1/2. And I've done an informal proof here we have diameter AB, we have a chord BC, we have angle ABC, and that actually intercepts arc AC. And what we've done is drawn a line to create an isosceles triangle using equal radii lengths. So we have two congruent angles, and we have a remote exterior angle. One of the things we know is that angle B and angle C are equal, and we can substitute angle B for angle C, and so now we can state that 2 times the measure of angle B equals the measure of arc AC. So arc AC is 2 times the measure of angle B, or angle B is 1/2 the measure of arc AC. Example 1, find each measure. So the measure of angle VYW is what we're looking for, and VYW is half of arc VW, so 1/2 of 60 equals 30. Part B of example 1, we're going to find the measure of arc WX. One of the things we can look at is we have an angle measurement here. So this angle intercepts the arc VX, and the angle is 55 degrees, so arc VX would be 2 times that angle, which is 110, and we can subtract VW from VX, and 60 from 110 equals 50 degrees. Theorem 8.4.2. Incongruent circles are the same circle. Inscribed angles are congruent if and only if they intercept congruent arcs. Let's look at angles 1 and angle 2. They both intercept arc AB, so consequently they'll both be half of the measure of arc AB, so they will be congruent. Theorem 8.4.3. An angle inscribed in a semicircle is a right angle. This is what we showed on the slide where I said it appears the two 90-degree angles, that there were two 90-degree angles. Well, now we see the picture of that. We have a diameter, we have a semicircle, and another semicircle, and this angle is intercepting the bottom semicircle. That semicircle is 180, so that angle would be 1/2 of 180, which is 90 degrees. In Theorem 8.4.4, we have opposite angles of an inscribed quad are supplementary. This is actually not new news. We know about this from doing quadrilateral theorems, but we have angle A and angle B will be supplementary to each other, B and C will be supplementary, and so on. Each one of those, because they're sup, will be 180 degrees, and you can use this to also prove your angles inside of your circles. Example 2. Find each measure in the figure with circle P where arc DAB equals 208 degrees. We're to find the measure of angle ABC. Well, angle ABC intercepts the diameter, so it'll be 1/2 of 180, so that will be 90 degrees. Find the measure of angle BDC. BDC is intercepting arc BC, and BDC is also equal to angle BAC because they both intercept the same arc. We know that BAC was intercepting the semicircle. So it's 90, and then we can subtract 68, which equals 22 degrees. So both angles intercept the same arc, and the acute angles of a right triangle are complementary. Some more information to dredge up from the past. Example 2. Find each measure in the figure, and we want to know the measure of angle DCB. Well, that's half of the measure of arc DAB, which we know is 208, so its measure is 104 degrees. And we want the measure of DAB, which will be 180 minus DCB, so 180 minus 104 equals 76 degrees. Now, opposite angles of an inscribed quad are supplementary. So this is where you can use that in your drawing, and it would benefit you to draw this and add all the arc measures in there so you can see it clearly. Your homework. Number 1 through 13, 17 through 21 odd, 24, 27, and 29. Let's look at some homework examples and put this into practice. So number 13, if the measure of arc ADB equals 290, then the measure of angle 1 equals, well, angle 1 intercepts this arc AB, and the arc AB is the piece of the circle that was not the 290. So 360 minus 290 equals 70. And the measure of angle 1 will be 1/2 of AB, arc AB, which will be 35 degrees. Number 17. If MLO equals 212, find angles MNO and MLO. So, angle MNO equals 1/2 of, MNO equals 1/2 of the 212, which is 106. And angle MLO equals, and I did this 2 different ways. I prefer my method to what the book was going to introduce. So the whole circle is 360 degrees. If we minus the 212 from the arc MLO, you have 148. And MLO is intercepting the arc that's 148 degrees, so 1/2 of that is 74. The book also used supplementary angles, and they subtracted 106 from 180, and they got 74. So there's more than one way to do that. And for the last problem, find arc RS and the measure of angle SQR. So arc RS is the arc that is intercepted by this 42 degree angle right here. So if it's 42 degrees, we know it's half of arc RS, so RS would be 2 times 42, which is 84. And angle SQR intercepts the arc 84, so that angle will be 1/2 of the arc RS, so that will be 42 degrees. And your text wanted you to know that it's also equal to angle RTS, because that intercepts the arc 84. So there's, once again, more than one way to do this. If you have any questions, be sure to contact me, and we'll meet again in the next video.